Hey guys, this is Dusk with an update here. So what you're looking at is my backyard. A massive trench with some broken pipes along the way. Turns out that the gas and the electrical needed some work to get the studio happening. So we had to trench new lines. At any rate, the funny story is after going to all the trouble to trench the electric and the new gas line, the electrician came in and said, "Oh, I don't need to trench because I'm going to take a different approach." And I'm actually going to document this for YouTube because this is something that's good to learn. So this is the inside of my main panel. You can kind of see what's going on. We've covered all this in the class, by the way, so you guys should understand what's going on here. Basically, what's been decided, rather than punching out the bottom and going through the trench all the way around, the electrician said, you know, why don't I just go out through the top of this into the garage on the other side of the panel, and we're going to go over along with this conduit, which ties into this LB down here at the floor. That actually has all the power from my studio in it. We're going to get into why I need to replace that in a second, but his idea was, why go through the ground if I can go above? And in the process, we're going to go ahead and put a sub panel right here, which will allow me to eliminate all of these lines that are just dangling and poorly installed. There's actually a lot of code violations with the way this stuff has been done, so we're going to go back and fix it and make it right. So moving on, this is the old gas line. It has a leak, so we had to replace it, and tore up what was once a beautiful backyard. But it's okay, it's nothing that a little bit of money won't fix. At any rate, we are trenching in lines as discussed. What I want to do is take you over to the studio though and show you what's happening and why we need to do this. By the way, that second gray pipe, the one right there in the middle, is actually the carrier for my current studio. Okay, so coming into the studio here, I'm going to use this as a sort of an object lesson of how the stuff that I tried teaching in my electrical class is actually important to somebody that wants to do music recording. So if you look here, this conduit and this wire coming out of the conduit, this is actually the lines that feed current to the main bus right here. So we're getting a good look at what I talked about in my electrical class. You see the two black wires. Those are the two 110 legs come in and hit the bus. And if you look, it's kind of hard to tell from here, but if you look right there in the middle, I think it says 8AWG. That stands for number 8 wire, American wire gauge. So what that means is we're running at least 200 feet as far as I can guess. And we've done the math and realized that the gauge of this wire is not thick enough for the 50 amp circuit that's feeding it. So what that means is it's actually possible to draw more current through these wires than is safe, because the wire could melt before the breaker would kick off. Again, this is all theoretical, but you don't want to set yourself up for failure, and that's exactly what the previous owner has done here with these black legs. So what we're going to do is we're going to sort of rebalance some things. We're going to replace a breaker on the main panel to match the load that these wires expect to see, and then we're going to add a sub panel in this room, either above or below, that's going to be a separate leg that we will use to power my air conditioning. What does that mean? Well, it means that I'll have a 40 amp main for my studio that will have its own dedicated circuit with its own isolated power, and then of course I'll have a separate circuit somewhere in the vicinity of this panel that will be a separate feed with 4 wire, that's 4 American wire gauge, that'll allow me to run at least 50 amps to power air conditioning and utilities for the studio. These are things that you don't really think much about until you're in the field realizing like, oh crap, I need to deal with it. So this entire panel is going to be gutted and rebuilt, and then we're going to add another one to it. So we actually have 2 separate sub panels one dedicated for the studio and another one dedicated just for service and power. And also while we're on the subject of bus bars and neutrals, you might recall in my electrical lecture we talked about how the electrician takes all of the hot wires. In this case, you can see all the black wires going into the circuit breakers. There's a red one there. In this case, the color is not relevant. And then we've got one white wire here. It shouldn't be white, I can tell you that much. But this is what's actually feeding the circuit breakers. That's my current, the hot lay. If we look behind there, we can see this bus bar that has all of the ties for the neutrals in it. And there's even a piece of bakelite or something on the side just to prevent any potential short to the chassis, because that neutral needs to be basically isolated from the chassis until they reach a certain point. And I'm sure there's a tie down point for the neutral. It looks like it's in there somewhere, but it's so dirty and full of cobwebs I can't see. At any rate, it's a highlight of why I think it's important for young engineers to understand how electricity works, and why I spend so much time at the beginning of my class covering this stuff, because it is pretty critical to understand how this works. And more importantly, when you get an electrician out in the field who doesn't understand what we do in the studio world, as the electrician that came in here today was, he's a smart guy, knows his stuff, but he didn't quite understand what I needed. And I was at least able to express to him in words that he understood to really get the idea of how studio grounding is supposed to work. So now we're all working on the same page. It's going to cost me a little more money to do it right, but when it's done, it's going to be done right.